Okay, so normal line, they want you to use the perpendicular slope when writing the equation. Tangent line, they want you to use the parallel slope. All right. So again, let's use the difference quotient. We have x. X is what? X is 1. And x is a when it's given. When x is not given, you have to substitute a into the curve. But when x is given, you go ahead and substitute what x actually is into the curve when you're substituting a plus h. So we want f of 1 plus h minus f of 1 all over h. So plug in 1 plus h into the function. Plug in 1 into the function. So this would be the limit as h approaches 0. And I forgot my limit as h approaches 0. So this would be the limit as h approaches 0 of 4 minus 1 plus h squared minus, but you got to keep the formula the same, minus, now plug in 1 into the function. So this would be minus 4 minus 1 squared. So you want to be careful here because whatever you get inside this parentheses, you have to take its opposite because of the subtraction sign in the formula. All over h. All right, so then we have the limit as h approaches 0. Bring over my 4. And then I'm going to multiply this out first, then take the opposite. That's what this means. You got to do order operation. So I got to multiply this out first. So I'm going to put minus. Multiply this out first. So this will be 1 plus 2h plus h squared minus, again, don't change the formula. And then you work this out. 4 minus 1 squared. Well, 1 squared is 1. 4 minus 1 is 3. And so you want to have a negative 3. So again, 1 squared is 1. 4 minus 1 is 3. But you got to take the opposite. So this would be minus 3 all over h. All right. So now we take the limit as x approaches 0. And we got to distribute this negative sign. Distribute this negative sign. So this would be 4 minus 1 minus 2h minus h squared minus 3 all over h. And then 4 minus 1 is 3. Minus 3 is 0. So again, that cancels with this. Something should always cancel. So we get the limit as h approaches 0 of negative 2, negative 2h minus h squared over h. Can't plug in 0 yet because we have, it would be 0 in the denominator. So you keep going, keep working at it until you can get, so you can plug in 0 where 0 is not in the denominator. So this would be the limit as h approaches 0. We're factoring, or we're simplifying, same thing. So this would be negative 2h over h minus h squared over h, which is the limit as h approaches 0 of, so this reduces down to -2. And then we got 2 h's here, 1 h here, so that reduces down to -h. All right, so now we can plug in our 0, because plugging in 0 here will not give us an undefined answer. So we plug in the limit as h approaches 0 of -2 minus 0, which is -2. And what is this? This is our parallel slope, right? So it didn't ask us, but it won't hurt. If we were to write our tangent line, we would use m equals -2. But they asked for a normal line. And in a normal line, you want to use perpendicular, which is what? It is the opposite and the reciprocal. So the opposite of a negative is a positive, and the reciprocal of 2 is 1/2. So you must use positive 1/2. Okay? So we have our slope. What else do we need to write our equation? We need a point. Well, we only have x. Everybody look back at the top here. They only gave us x. So we need a y. And what do we do to find our y? Well, you plug it back into this equation, because remember, f of x is y. So you plug it back into this equation, which we actually already did when we plugged it in here. So we got 3. So, and that should make sense. So 1 squared is 1, and then 4 minus 1 is 3. So our ordered pair when x is 1, so our ordered pair when x is 1, y is 3. X is 1, y is 3. Okay? So to get it, so they gave us our x. They did not give us our y. So to get our y, so I'm going to try to squeeze this here. To get y, plug in x into curve. Okay. So we're almost done. It's a lot of work, but it's not hard work. All right, so y minus y1 equals m times x minus x1. So y minus 3 equals -2 times x minus 1. Y minus 3 equals -2x plus 2. Add 3 to both sides, so y equals -2x plus 5. Hopefully, I'm tired. So then our normal, y minus y1 equals m times x minus x1. Y minus 3 equals 1/2 x minus 1. Y minus 3 equals 1/2 x minus 1/2. And then add 3 to both sides, and you get 1/2 x. What is this? Plus 5/2? Hopefully. That's 5/2. That should be 2.5. All right, and that's our normal. So recap. Let's recap. It asked us to write an equation for the normal curve. It gave us x. It didn't give us y. So how did we get y? You plug x into the curve. So we got our y by plugging in x here, and we got 4 minus 1 squared, which was 3. So that's how we ended up with 1 and 3 as our point. Okay? However, to get our slope, since they only gave us x or they only gave us a point, you can't use the normal equation for slope, you have to use the difference quotient because you are only given 1 point. And since we were given x, you substitute x for a and then plug that into the curve everywhere you see x. So I saw 4 minus x squared, that turns into 4 minus 1 plus h squared because we were plugging in 1 plus h. Then I need to plug in 1, so it turns into 4 minus 1 squared. So I plug in 4 minus 1 squared, but again, the subtraction sign is called the difference quotient. So it's the subtraction sign you have to keep. You can't change it. And so whatever you get in here turns negative, or turns to its opposite, I should say. Okay? And then a couple more things, and then I'm done. Instantaneous rate of change or instantaneous speed, you're still going to use the difference quotient, except that you're going to substitute time or t where you see a. But it's still x, it is still a. You just use a different notation when you are dealing with instantaneous rate of change or instantaneous speed. So let's look at a problem like that. Let's look at page 91, example 6. So it says, find the speed of a falling rock. In example 1, section 2.1, at t equals 1 second. So we're find the speed of a falling rock using f of t equals 16t squared at t equals 1 second. So now that we're dealing with time, it's still the difference quotient. It's just now is the limit as h approaches 0 of f of t plus h minus f of t over h. So same process, different notation. So this would be the limit as h approaches 0 of, we know what t is. T is 1. So this is f of 1 plus h minus f of 1 over h. So everywhere I see a t in my function or my curve, I'm going to put 1 plus h. Minus everywhere I see a t in my function, I'm going to put a 1. Okay? So we have the limit as h approaches 0 of 16 times 1 plus h squared. So everywhere I saw t, I'm going to put 1 plus h. But you have to finish off the function. You have to put everything around or in front or in back of your t. Minus, now everywhere I see a t, I'm going to put a 1 in my function. So this would be 16 times 1 squared all over h. So this would be the limit as h approaches 0. And again, you got to multiply that out, then multiply all of that by 16. So this would be 16 times 1 plus 2h plus h squared minus 1 squared is 1. And 16 times 1 is 16. But it's going to be minus 16 because the formula says difference. All over h. Can't cancel this out yet because you have parentheses. I know a lot of you are going to want to be tempted. Oh, let's cross these 16s out. Ms. Gibson said if something cancels, something should cancel. 16 minus 16 cancels, but that's not order operations. Order operations say you multiply before you subtract. So we got to distribute that first. So it'll be the limit as h approaches 0 of 16 plus 32h plus 16h squared minus 16 all over h. Now, parentheses are gone. Now we can cross out the 16s. And can we plug in 0 here? No, because we'll get undefined. Got to keep going. So this will be the limit as h approaches 0 of 32h plus 16h squared over h. Factor, simplify, same thing. So this will be the limit as h approaches 0 of 32h over h plus 16h squared over h. That makes a 1. It's 2 h's here, 1 h here. So you simplify that down, and there's an h left. So this would be the limit as h approaches 0 of 32 plus 16h. All right. So now, if we plugged a 0 here, will that give us an undefined slope? No. So finally, we have the limit as h approaches 0 of 32 plus 16 times 0, which is 32. And they have units. So remember, average rate of change, instantaneous rate of change usually have units, which I negated to say at the beginning. So, but this is feet. I forgot to say we were dealing with feet. Well, I said seconds at the top because it was the rock was falling over 1 second, but I didn't say the feet. So the unit is 32 feet per second. So that's what the rock is doing. It's falling at a rate of every 1 second it's falling 32 feet. Okay. So that should be enough to do your homework.